Good morning, friends. Today we are going to revise the unit 3. In that particular unit, we have seen the reaction and the reactivity of the halogenated hydrocarbons. In that, we talk regarding the organomagnesium organolithium compound. Then we talk about the alkyl halide, then aryl halide. Then we come to know the alcohol phenols and the epoxides. This was the part which was covered under this unit. We have seen this in detail. Today I am going to revise this part again. See what is called as the particular that halogenated hydrocarbons. If hydrocarbons is nothing but the compound having the carbon hydrogen, the hydrocarbons are nothing but the compound containing the carbon and hydrogen. If, as we know, if the hydrogen, one of the hydrogen from this hydrocarbon is replaced by the halide, then we can call it as a halogenated hydrocarbons. Then we have seen the nomenclature of these particular compounds. In the first structure, at the time of the lecture, I said that we have to replace the second hydrogen carbon on second hydrogen from the second carbon. We have to replace from the that particular chloride atom. It will give you the secondary propyl chloride, or you can name it as the IUPAC can be written as, you have to number to the carbon series, then you have to consider the longest chain, then you have to give the name of the alkane to the longest chain, then you have to number to that chain so as to get the halogen group as the lowest possible number. Here in the first example, you can name a number from any one side, you will get the same number for this particular chlorine. That one of the hydrogen from this carbon you have to replace from the chlorine, and it will gives you the 2-chloropropane. Similarly, you can try it for the different example. We have seen the different example. You can try the more number of example. Here the instead of the chlorine you can take the bromine, iodine. Here the tertiary butyl chloride iodide is there. You can take the tertiary butyl chloride. You can take the tertiary butyl bromide, so on. There is no bar for this particular thing. You can take the any example. You can try for the any example. Please try to get that the how we can nomenclature, how we can make the name to this particular thing that we have to see. Then we have talked about the organomagnesium compound. These are nothing but the organic moiety is bonded to the magnesium, that are called as the organomagnesium compound. They are also known as the Grignard reagent. They are nothing but the alkyl or say aryl magnesium halide, represented by the formula RMgX, where R is the alkenyl cycloalkyl or say heteroaryl group. X is nothing but a Cl minus, Br minus and I minus. Again, we have seen the name for these things. You can try the different examples for this particular organomagnesium compound. You can take the ethyl magnesium iodide, ethyl magnesium bromide, ethyl magnesium chloride, methyl magnesium iodide, methyl magnesium bromide, and so on. You can take anything. Now, when we in this particular organomagnesium compound, we talk about the nature of the carbon metal bond and reactivity of the carbon metal bond. Nature and the reactivity of the carbon metal bond. As we seen that carbon is the when carbon is linked to the metal is highly electropositive. That's why metal will carry the delta positive charge, whereas the carbon will carry the delta negative charge. That carbon atom will bonded to the metal. The electrons and the bonds are strongly attracted towards the carbon by creating an ionic character in the bond and makes the bond polar, with where metal is a more electropositive. Hence, organometallic compounds do not exhibit 100% covalent character, because the metal as the electronegativity of the metal increases, the ionic character of the carbon metal bond also increases. Carbon act as a nuclear file. Here the order is given how that particular thing is depend on this. Then we talk about the reactivity and the types of the organometallic. On this basis of this particular carbon metal bond, organometallics can be classified as ionic OMCs, covalent OMCs, compound with multi-centered bond, and pi coordinated OMCs. These are the different types of this particular OMCs that we have seen. In the ionic OMCs that we have seen, that highly electropositive alkali and alkaline earth metal except the lithium, beryllium and magnesium. The bonding electron of the carbon metal bonds are attracted towards organic group, making the bond highly polar. Sodium, potassium, calcium, these are the highly electropositive element. This compound behaves like the salt and soluble in the water, polar solvent, and they are highly reactive and shows the nucleophilic character. Example is given. Then the covalent OMCs, these are the compound formed with the electropositive metal like the aluminum, zinc, magnesium and etc. A covalent bond is formed between the carbon and the metal which has two electrons between atoms. Since carbon metal bonds are partially polar. Then these compounds are less active and less soluble than the ionic OMCs. Here example Grignard reagent RMGX, CH3ZnI, iodomethyl zinc or say methyl zinc iodide, you can name like this. Then the diethyl zinc compounds with the multi-centered bond. These compounds are, here the example is given, intermediate between ionic and covalent organic OMCs. The bonding in this compound is not conventional as 2 electron to center type. Here you can see there are 3 centered bond and they are electron deficient in nature, hence they are also called as the non-classically bonded OMCs. Pi coordinated, the benzoid and the non-benzoid aromatic compound has delocalized pi electron. These pi electrons and the lone pairs of the electrons can coordinate with the transition metals and forming a complex. Hence these compounds possess coordinate bond between the carbon and metal. Here you can see the ferrocene is the example. They are also called as a sandwich compound. Then how we can prepare this particular OMCs? We have seen OMCs can be prepared from the alkyl halide in presence of the dry ether at the 35 degrees centigrade. You will get the formation of the RMGX. Then you can take the different substituent reactant and you can prepare the different RMGX. Then the organolithium compound, these are when organometallic compound which contain the carbon and the lithium bond are called as organolithium compound, and they can maybe the aryl or say alkyl lithium. Preparation from the alkyl halide, you can prepare it from the alkyl halide. You have to take the dry hexane -10 degrees centigrade, nitrogen atmosphere should be there. Then from aryl halide you can prepare that organolithium compound. Then reaction of the organometallic compounds with the Grignard reagents, compound containing acidic hydrogen with carbonyl group, then with carbon dioxide, with cyanide and with epoxide. In the compound containing acidic hydrogen, we have to see the reaction of this particular Grignard reagent with the water, ammonia, alcohol, terminal alkyl is bonded compound, primary arynes. Then first of all, reaction of the Grignard reagents with the water, you can see C6H5MgBr plus H2O, it will give you C6H6 plus MgBrOH. Then with ammonia we have seen the reaction. Always you have to write the dry ether on the arrow. Okay, please note that these reactions, very simple reactions there that we have already seen. We will see again. Here we will stop. Thank you.